already we know it. Impulse we know, angular impulse we know, momentum we know, angular momentum we know, torque we know, force we know. That's all we applied it. So this is what happens in rigid body. Ideas are very less, means concepts are very less, but the application part becomes very wide. And the particle is exactly at the midpoint. Sir, then what is the remedy, sir, for this? What is the remedy? Remedy in the sense, the more general idea, the more general information, if you know, after collision, the particle is brought to rest. I think this much is what we have. The particle has come to rest here. Keep it here. This is the velocity of center of mass. This is a point P. What is our question? Finally, what is asking? That impulse at the inch, the inch, horizontal impulse. And just after impact, what will happen to rod? So don't bother. Say, leave the question. What happened to rod? Will rotate, no? Sir, how the weight will act? In fact, let me get you into the problem. G will act here. You don't bother anything question. After impact, what will happen to the rod? Will rotate, as we know. Okay, let's go for rotate. We'll calculate that omega first. How to calculate that omega? How to calculate that omega? How to calculate that omega means conservation of angular momentum. Why only conservation of angular momentum? About the inch only. Now let me go for during collision. This is what happens, no? Here, an impulse on the rod, J1, the impulse on the particle. Then there'll be impulse at the inch, impulse by the inch on the rod. Sir, in what direction you are assuming? So let me assume any direction. I'll solve it. Inch, I'll write. Shall I write JH? Impulse by the inch on the rod. I think towards left. It should be towards left. The rod wants to move. Why the rod will move? Because of J1, it wants to move. You see, it's quite very simple. No, the inch will not permit JH. Say you do one thing very simple. You take pen, hold it at one end, with other hold it with your hand. You try to push it. So it is like this. What I'm discussing is of this one. I'll push it. So what this pen, it actually it wants to move. No, it wants to move. So my fingers in what direction will my fingers, thumb and pointing finger. So now you see that one. So the pen actually wants to move, but because of hinge, it can only rotate. Getting the idea here? So now what happened? If these fingers were not there, what happened? You would have moved like this, no? So tell me, like my fingers, this one, fingers, I think I have 10, but look at the one which I have holding the pen. So these fingers, what happened? In what direction the exert force on the pen will be in this direction? It wants to move. So therefore, these fingers will exert force in this direction. I think you can experience this, nothing big. Okay, let's get into the calculation part. Now, first we'll get the omega. About what point I should consider? About H only, or select about the point P. LPZI equal to LPZF. I think this everyone knows by this time. What is the length? MVL by 2. Length of the rod, L by 2, should be equal to IP omega. And the particle has come to rest. The particle has come to rest. So therefore, angular particle will be 0. So this will be MVL by 2, ML square by 3 omega. Omega equal to how much? 3V by 2L. And what is the sense? This will be, it will be anti-clockwise. Okay, now we got it. How to bring that impulse again? Will there be any velocity of center of mass? Will be there? There'll be velocity of center of mass. So the center of mass will have velocity. How much it is? Vc. So the effect of impulse is such that Vc. What is Vc is equal to? L by 2 omega. At that instant, we are discussing everything at that instant. So L by 2, 3v by 2L. So 3v by 4, velocity of center of mass. Then from where that velocity is, is it only due to J1 or due to J1 minus H? J1 minus H. So this will be J1 minus JH equal to MVC with respect to center of mass. For motion of center of mass. Okay, now VC, I know it. Somehow if I can get J1, problem solved. From where to bring J1? I look at the particle, on particle. On particle. Now, what is the initial momentum? MV. Why did it has come to rest? Because of impulse J1. Is it okay? I'm showing all things clearly. And finally, it has come to rest. So what is J1 equal to MV? So this is equation 1, 2. 1, 2, and 3. Let me use 1, 2, 3, 4. From 1, 2, and 3. J1 is equal to how much? MV, JH, M, 3V by 4. So what is the impulse? MV by 4. I got positive. I got positive. What does it mean? What I assumed is correct. The impulse by the hinge on the rod will be towards left. It will be, what is this? By the hinge on the rod. Getting some methodology here. So all these problems, what happen? You are got adjusted to what, like some situation, apply some concept, some formula. I think here is what you have to really think in some alternative methods. This is what I shown for what? Rod. Now I will suspend a disc. Then I will suspend a triangular plate. I'll suspend a cone. Finish over. So what all we studied for rod, you should extend for any other rigid body. All this not there much in most of the books here, but possibility of asking in advance. The reaction. That's why I think from the talk when we started, no, from there only I started pulling up, no, the hinge reaction at the hinge, reaction at the hinge. That one. So always whenever a rigid body is suspended, think about the reaction at the hinge, because that is the core central idea. So that's why the angular momentum is not considered because of JH acting. That's why angular momentum is not considered about center of mass of the rod or about any one line because of this JH. Suppose since a particle will not come to rest, can we find out? Can we find out impulse, this impulsive reaction? Or only when particle comes to rest we can find out? Yes, we can find out. In that case, what happened? We should calculate the velocity v1. To make problem little bit, we should focus more on to get JH. I made it a test. Practically what happened? After collision, the particle may rebound. Okay, let it rebound. Then from here what happened? I'll write the velocity of the rebound. For that, I'll write quotient of restitution formula. I'll get this velocity. Then I'll get J1. Now, don't think that particle come to rest, we can find